All right, guys, so I'm just going to run through how to work out all the problems on the review. Again, as usual, feel free to fast forward, pause, rewind, right, whatever you need to do to make sure that you understand every concept and that you are ready for your Unit 1 test. Okay, so here we go. This first section is solving equations. So again, our whole goal is to get the x by itself, right? Remember, we're trying to unbury the x. So anything that's on the same side of the equation with the x has to get moved to the other side. But you just can't pick it up and move it, right? You have to use the inverse or the opposite operation in order to move something to the other side of an equal sign. So in this case, we're undoing the minus 12. So we are going to add 12 to both sides. Because negative 12 and positive 12 cancel, which is going to end up giving us 58 for the solution of x. All right, remember, we can always type it back into the original equation and substitute 58 in for x and check our answers, right? All right, hopping over here. The first thing that should jump out at you about this problem is the parentheses and the fact that we have multipliers in front of the parentheses. So anytime you see multiple terms inside of a parenthesis, that means this multiplier has to get distributed or multiplied by each term inside. All right, so when we multiply 3 times x, of course, we just write that as 3x, and 3 times positive 2 is positive 6. And then I want to make sure I bring down everything else that's on that side, so that plus x. I'm going to draw my little line here. And then, of course, on the right-hand side, when we multiply everything inside by 2, we get 2x minus 6. Now, you can move terms over like one at a time, but the smart thing to do at this point would be to see if you have any like terms. Like on the right-hand side, these are not like terms, right? It's an x term and a constant. I cannot combine those. But if I look on the left-hand side, I notice I have a 3x and a positive 1x, and those can be combined, right? Because they are like terms. So 3x plus 1x gives me 4x, and then I bring down the plus 6. So I always want to simplify my expressions by combining like terms on both sides, if I can. If I can't, then my goal at this point is to get all of my x terms to one side and all of my constants to the other. And which side you take those to is totally up to you. I'm going to choose to subtract the positive 2x's, because remember, these are technically being added, right? Because this minus sign does not belong to the 2x. He belongs to the 6 behind him, right? So we're going to subtract 2x from both sides because a positive 2x minus 2x cancels, right? And that's going to give us 2x's. And now we're kind of down to just a basic two-step equation, right? Hold on, I'm going to scooch all this up a little bit. Give myself a couple more steps of room. All right, and then we need to get all of our constants to the other side. So we need to move that plus 6 away from the x. So that's going to leave us with 2x equals negative 12. And then, of course, we need to get rid of the 2 multiplier on the x. So we're going to divide both sides by 2, because those will cancel. And voila, we're going to get x equals negative 6. Right, a very multi-step equation, right? But it's the same steps every time. Get rid of the parentheses by distributing. Combine like terms. Get all your x's to one side. Get all of your constants to the other. And then divide by the coefficient in front of the x. It's the same steps over and over and over again. All right, next up, let me change colors here. Go to a nice pretty blue. There we go. All right, so I notice I have parentheses and I have a multiplier in front of said parentheses. So I'm going to multiply. So 0.50 or just 0.5, which is the same thing as a half, right? So 0.50x plus, and of course a half times 2 would give us 1 because half of 2 is 1. All right. Sorry, I'm going to draw my line there. And then, of course, there are no parentheses on this side, so I'm going to go ahead and just bring all that down. Now, technically, you can kind of stop here. If you want to go ahead and get all of your, because you notice how everything on the left side is perfectly identical to everything on the right side. So if you want to go ahead and get all your x's to one side, you certainly can, or you can just literally stop here, right? Because if I subtract half an x from both sides, right, the x's disappear, and I'm left with the statement 1 equals 1. And I'm going to put a little question mark there because remember, this is a special case scenario. When all of your x's completely disappear, right? Because when you subtract them or add them to both sides, they all go away, right? The question is are we left with a true or a false statement? So you're asking yourself, is 1 equal to 1? Yes, it is. So that's true, which means this equation actually has infinite solutions. Any number in the universe that we could possibly think of, we can plug in for x, and it would make this equation true because the left and the right sides are identical to one another. Now, if you did this problem and you got something like 1 equals 5, well, that's not a true statement. So that would be your no solution special case, right? All right, moving on to our last one. So we have a fraction and we have parentheses. So there's 2 different ways you can go about doing this problem, right? If you want to distribute, you can. I would not suggest it because if you distribute, you're going to get 1/3 x plus 2/3. So you took a problem, an equation that has only 1 fraction in it, and now you have 2, right? But you're totally welcome to do that, right? There's absolutely nothing wrong with that. In fact, you know what? I'm actually just going to go ahead and do it that way. Let's keep our steps consistent, right? So when I multiply, I get 1/3 x plus, and 1/3 times 2 is 2/3. And if you don't feel super confident about your fraction work, remember that's 2/1, and you're just multiplying top by top, bottom times bottom, or you have a calculator literally in your hand at all times during class, right? So use your calculator and just type it in, okay? Now I'm going to bring down my equals 6. And it's at this point you're like, wow, that's a lot of fractions with a denominator of 3. So remember, anytime we have a bunch of fractions, the easiest and most effective way to get rid of your fractions is to multiply every single term in the equation by 3. So I'm going to multiply this term by 3. I'm going to multiply this term 3. And I have to multiply the 6 on the other side by 3. Everybody has to get the 3. And the cool thing is the 3 multiplier and the 3 divider in my fractions, they will cancel because they are inverse operations. So now what I have left is 1x, right? This 1x right here, right? I'm just going to write x. There's an understood 1 in front of it, plus, and when all my 3's canceled, I still have a positive 2 sitting on the top. And then, of course, 6 times 3 gives me 18. And I went from a gross looking equation that had a bunch of fractions in it to this nice easy equation of x plus 2 equals 18, where all I need to do is undo the plus 2 by subtracting 2. And that's going to give us our solution of x equals 16. All right. Now, you could have multiplied by 3 right from the get-go on both sides because this is all technically one term. So these 3's would have canceled out, and you would have seen that you get your x plus 2. Sorry, I don't know why I just wrote 8 right there. That's so silly. Sorry about that. So you automatically get to your x plus 2 equals 18 step that we got right here, right? So that does get you there a little bit faster. But again, I just want you to kind of stick with the plan and kind of stick with the solution strategy and just use that all the time, right? So we don't get confused. All right, the next section is solving inequalities, which is the exact same as solving equations, except you have to remember to flip the inequality symbol when you divide by a negative, right? Flip the symbol if, that looks weird, sorry. If you divide by a negative. And that's usually going to be in the very last step of your solving process. Okay, when we divide, it's usually the very last thing. So if you happen to be dividing by a negative number, then you have to make sure that you keep the truth value the same by flipping the inequality symbol the other way. All right, we did a whole little experiment about that in class in our notes, if you remember. All right, so here we go. On this one, it's just a normal 2-step algebra equation, right? So we're going to add the 2 to both sides. Those 2's are going to cancel. And then we are left with 5 is less than or equal to 5n. And then, of course, we're going to divide by 5. Those 5's cancel. And then n is greater than or equal to 1 is going to be our solution. Now we have to graph that. All right, I'm going to pause really quick. I need to go run and get a charger really fast, so give me a sec. Okay, sorry about that. Now, a lot of you guys on your homework and your quizzes, you're getting this answer correct when you solve the inequality, but you are not getting your graph correct. And that's because we are confusing how to read our inequality answers. Give me one sec. Okay, so whenever you read an inequality, I suggest always read it from the variable first. So because the variable is on the right-hand side, I would highly suggest you read it from right to left, because this says n is greater than or equal to 1. And I know some of you guys like to switch it all around, that's also totally fine as long as you keep the symbol, noticing how he's opening up towards the n. If you flip it all around, you have to make sure that he's still opening towards the end, right? The alligator mouth is eating the n. So we would call this n is, I'm just going to write this all out. You don't have to do this, of course. N is greater than or equal to 1 is how we would pronounce that. Right? So that's what you're graphing, right? So here's the 1. If you want to put a couple of other numbers around it, you certainly can, right? And then the question is it an open circle or a solid circle, right? And that depends on whether you can actually equal 1. Can I actually land on the 1, right, and actually be equal to 1? And yes, I can, because right here it says or equal to, right? It's not just greater than 1, it's also or equal to, right? So we definitely need a solid dot on the 1 because we can equal 1. And then we want to figure out where all the values of n are greater than 1. Well, all the values greater than 1 are clearly to the right. Right, like 2, 3, 4, 5. These are all numbers greater than 1. Okay, so make sure that you are interpreting your answer correctly. And just because this is pointing to the left doesn't mean your arrow goes left, right? It depends on which side of the equation your variable is on. Okay? All right, I think I've harped on that enough. Here we go, next one. All right, so I'm going to kind of stay consistent with what I just did on number 4, and I'm going to go ahead and get rid of my parentheses first. You do not have to solve it the same way I'm doing it. We'll all get the same answer if we were solving it correctly and not breaking any math rules. Okay, so I'm going to go ahead and stay consistent with what I did a second ago, and I'm going to go ahead and multiply through by 1/3. So that's going to give me 1/3 x plus 2/3. Again, use your calculator if you need to, but that 2 is over 1, and then we're just multiplying straight across. 1 times 2, 3 times 1. And then is greater than or equal to 1/2 x minus 4. Now at this point, you can do a bunch of fraction work and stuff if you want, but for me personally, I'm going to do exactly what I did up here. I do not like solving an equation, or in this case an inequality, that has 3 out of 4 terms are fractions. But we can get rid of that by looking at what our denominators are, because that's what we're trying to get rid of, right? That's what's causing the fraction to even be there in the first place. And I want to ask myself, what is a number I can multiply through by to get rid or cancel out the 3 and the 2 at the same time, right? And that's going to be their least common multiple. So if I start counting by 3s and then start counting by 2s, 6 is going to be our winner, right? So I'm going to multiply every single term in my equation by 6, because whatever I do to one term, I have to do it to everybody from a multiplication standpoint. And now this is where your calculator is going to come in handy, right? So I'm going to actually multiply 6 times 1/3, which is going to give me 2. And then don't forget to bring your x down, plus 2/3 times 6 is going to give me 4. Again, use your calculator. It's going to give you the right answer if you type it in correctly. Is greater than or equal to. All right, now I'm going to take half of 6. So multiplying 1/2 times the 6, which is going to give me 3. Don't forget to bring down my x term. And then, of course, here, this is just a big 4 times 6. So minus 24. All right. So now we're down to just kind of a normal looking algebra equation or inequality where we've got x's on both sides and constants on both sides. So we want to get all of our x's to one side and all of our constants to the other. Which side you move is completely up to you. Just for the sake of easiness, I'm actually going to get all my x's to the left because I think a lot more of you guys do better reading your answer when the x is on the left-hand side. So I'm going to go ahead and subtract the 3 x's over here. Because remember, those are positive 3 x's sitting there. So I'm going to move those over. And that's going to give me 2 x's minus 3 x's. It's going to give me negative 1 x's plus 4 is greater than or equal to negative 24. Please do not forget to bring the negative down. That he belongs to the 24. And then we need to get all of our constants to the other side. So we're going to subtract 4 to get those 4's to cancel out. So now we have negative 1x is greater than or equal to negative 28. And we're not quite done because we still have this negative 1 multiplier. So we are going to have to divide both sides by negative 1. And then little bells should be going off, right? Because we just divided by a negative. So we literally just switched the truth value of this entire inequality. So we have to make sure that we flip the inequality symbol to keep the truth value the same. And our answer is x is less than or equal to positive 28. Okay. Now I got to graph it. So here we go. Let's see. This is, I'm going to write it out just like I did last time. That is a less than symbol because it's x is less than or equal to, we love that part, that means solid dot, 28. All right, so let's just say this is the 28. I can equal 28 or anything less than that. And on a number line, all of my lesser numbers will be to the left. Get a little bit bigger line there. There we go. Okay, moving on. Here we go. One more of these. All right, so again, lots of parentheses. So I have a negative 6 multiplier that I need to distribute to those two terms. So negative 6 plus 12 is less than or equal to. And then, of course, I do have a multiplier in front of this parenthesis. He's a negative 1 multiplier. I do need to distribute him. So negative 1 times positive 4x is negative 4x, and negative 1 times negative 3 is positive 3. All right, and then just like we talked about before, you always kind of want to check at this point, do you have any like terms on the left side to combine? No. Do I have any like terms on the right side that I can combine? Yes, right? I can go ahead and combine negative 4x and x. Again, you're not adding or subtracting them to another side. You're just simply combining like terms because they're already on the same side and part of the same expression. So negative 4 plus 1 is going to end up giving us negative 3x plus 3. All right, and I'm bringing everything down. All right, and then we need to get all of our x's to one side. I'm just going to stay consistent and do what I did before. I'm going to go ahead and add the negative 3x's over here. And let's see, that's going to give us negative 3x plus 12 is less than or equal to 3. I'm totally running out of room, so if y'all don't, oopsies. I knew that was going to move that. Hold on a second. I'm going to scooch it down here to finish the problem. All right. Then we got a basic two-step equation, so we're going to subtract the 12. So that brings down our negative 3x is less than or equal to negative 9. And then, of course, our last step is to divide by negative 3. Again, little bells should be going off because we're dividing by a negative, which is going to give us x. And I got to flip that inequality, and that would be a positive 3. So x is greater than or equal to 3. All right, again, I'm going to write it out. X is greater than or equal to, I think it's weird that all of our examples are equal to, but that's okay, equal to 3. So that means we have a solid dot on the 3. Again, please remember, if it was not equal to, that's when we have an open dot. Okay. And it's x is greater than or equal to 3. So we need on the line where all the values are greater, which would clearly be to the right. Okay. All right, next up, literal equation practice, right? These are when you have lots and lots of letters and you're just trying to move all the other letters to the other side. So it's the same thing as solving normal equations, right? It's just, you're usually not going to be able to do a lot of simplifying when you move it to the other side. All right, so I'm just trying to find a new color. So this one we're solving for y. It does mean this y. I know it has a lowercase y, but anyway. So I really just need to get rid of the a multiplier and the x multiplier. And since they're both being multiplied, it doesn't matter that one's in front and one's behind. I mean, would you all agree that I could write this as axy if I wanted to, because the order we put multipliers does not matter, right? And so the fact is the y is getting multiplied by ax. So we just simply need to divide by ax on both sides to isolate that y and get him all by himself, right? Because the a's and the x's would cancel out. And that's how we get that y by itself. And then all that mess that we just moved over there, that's all your answer. Z divided by ax. All right, so just using the opposite or inverse operation, right, to move everything else away from the variable you're trying to solve for. Now in this case, we're trying to solve for y, but unfortunately, we have two y's. So we definitely, the first thing that we have to do is get them all to the same side. It doesn't matter if you want to take the positive 3y's over here or the negative or the positive 1y over here. It does not matter. I would prefer to keep my y's positive. So I'm going to subtract the 1y to this side. And then those would cancel, of course. And that is going to give me 2x plus 2y equals 4. Right, so that's objective number 1. If I'm trying to solve for y, I can only have one y. I can't have two. So I've got to get them all to the same side first. Now I just basically have a two-step algebra equation where I need to isolate and get this y all by himself. So the first thing I need to do is get that big 2x term moved to the other side. And he is a positive 2x, so we're going to subtract that whole term over here. And again, I'm just going to bring down my 2y. You cannot do anything with this 4 minus 2x, except literally just write it all out horizontally, because 4 is a constant and x is an x term, so they are not like terms. So you cannot subtract them from one another. Please don't try to. And then my last step to get that y by itself is just simply to divide out that 2 multiplier. So we're going to divide by 2 on both sides. And that's how we get the y by itself. And my answer is just that big mess after I've just moved everything to the other side one step at a time. I would totally accept this answer on the test, but this is telling us that we're dividing both of these terms in the numerator by 2. So if you actually want to go ahead, I'm going to write or. If you actually want to do the division, like 4 divided by 2 is 2, right? Because we can actually divide that. Oops. Sorry about And we can also do negative 2x divided by 2, which is just negative 1x. So I would take either one of those answers, whether you simplified it or not, that's totally up to you. My goal is just for us to get y solved for correctly. Okay. All right. The rest of this entire page is simplifying expressions. And this is what we just did last week, where we learned the difference, hopefully, between adding, subtracting, and multiplying polynomials. So again, I'm going to kind of put a little reminder box right here. You have to remember the basic laws of algebra, that when you are adding like terms, 2x plus 2x, you keep the term, right? When I add 2 x's to 2 more x's, I now just have 4 x's. The term cannot change. You're just adding more things together. Like 2 dogs plus 2 dogs is 4 dogs, right? I use that analogy a lot in class to remind you that if you're talking about x's and you're adding them or subtracting them from one another, then the x's don't change. It's still just x's, right? But when you multiply, I'm going to put but. When I multiply 2x times 2x, now it's 4x squared, because you add the exponents, right? When you're multiplying variables, now the term does change, right? Now they're not just x's anymore. When I actually merge them all together, right, you add the exponents. Okay, you have to make sure you understand. On our last quiz, a lot of you guys were flip-flopping on these rules and just like going back and forth. And these are the only 2 big, huge laws that you have to remember for Algebra 1. Okay? All right. So I'm going to put remember. All right. So now here we go. Number 10 says simplify each expression. Okay, well, this is clearly just an addition and subtraction problem. So literally this is just a combining like terms question. So you're asking yourself, are there any like terms? Well, this is an x to the 6th term. Are there other x to the 6th terms? Yes, there's another one right here. This guy's a constant, and I don't see any other constants. So he's just going to come down into my answer. But these guys are like terms, so I'm going to subtract 5x to the 6th minus 3x to the 6th, which is going to leave me with 2x to the 6th, right? Because the term doesn't change. I just have less x to the 6th to work with because I was subtracting. And then I bring down my plus 5 because there's no other constants to combine him with. And that's it, right? That's our final answer, right? We don't want to make things more complicated than they are. All right, number 11. This is a multiplication problem first because I clearly have a binomial inside a set of parentheses, and every term in that binomial has to get multiplied by that negative 2x. That is the whole purpose of the parentheses, is to tell us that each one of these terms has to get the negative 2x multiplier. All right, so we're going to multiply negative 2x times positive 3x. You multiply the numbers just like usual, and then of course x times x is x squared, because we add the exponents when we multiply. Then we have a negative 2x times a negative 1, and negative times a negative is a positive, and clearly 2x times 1 is still just 2x. And we're done distributing, so I'm going to bring down that plus x term that's hanging off on the end over here. And now that we've multiplied out the parentheses, now we're right back to where we just were on the previous problem. Now it's just an addition subtraction problem where we're looking for like terms. This is an x squared term. He can only be added to other x squared terms. And I don't see any other x squared terms. So I'm just going to bring him down. And then this guy is a positive 2x. He can only be added to other x terms. So looky there, I have another x term with 8x. So if I have 2 x's and 8 more x's, that gives me a total of 10 x's. And that is going to be my final answer. You also want to make sure that you're writing your answers in standard form, right? If you wrote your answer on the test as 10x minus 6x squared because you flip-flop the terms and put the 10x first, it's not wrong, but I would be taking it like a point off because this is not in standard form. Standard form meaning we always want the term that has the highest power to be written first, and then the term with the next highest power, and the next highest power, and the next, all the way down into the smallest power, or the constant. Okay, so you want to keep that in mind when you're setting up your final answers. All right, number 12 is very similar to number 11. I notice I have parentheses, and I have multipliers in front of those parentheses, right? So my first parenthesis has a 5x multiplier. So I'm going to multiply 5 times x, which, again, there's an understood 1 right there. So it's technically just a 5 times a 1, just like normal. Oops. So that's going to give me 5, and then x times x is, of course, x squared, because I add the exponents. And then 5 times positive 1 is positive 5x. And then I don't want to forget here, this parenthesis also has a number in front of it, and that is a negative 1. So I'm distributing a negative 1, which is going to give me a negative 1x plus 1. And now that I've undone all the multiplication and gotten rid of all the parentheses, now it's just an addition or combining like terms problem. So again, I'm going to start at the highest term, 5x squared. I don't see any other 5x squared terms, or x squared terms, sorry. So that means he has no like terms, so we're just going to bring him down. Then I have a positive 5x, so an x term, which can only be combined with other x terms. So I've got 5x's. I'm taking away one of those x's, which leaves me with positive 4x's. And then, of course, I have the positive 1 at the end. And he does not have any like term constant buddies anywhere, so he's just also going to come down. And that is our final answer, written in nice standard form. All right, moving on. Now this one, he has no plus or minus signs anywhere in between these parentheses, which means this is a straight up multiplication problem where every term in this parenthesis is getting multiplied by every term in this parenthesis. So this is a double distribution problem or a box problem, right? Because this 3x, he has to get multiplied by every term over here, and the positive 1 also has to get multiplied by every term over here. So we have to double distribute and multiply everybody together, right, in order to get rid of those parentheses. So just take it one step at a time. 3x times negative 2x is going to give us negative 6x squared. Because we are multiplying, we are not adding. We're getting rid of parentheses, so we're multiplying. It's a very important distinction to understand. When you're getting rid of parentheses, you are multiplying. And then 3x times positive 3 gives us positive 9x. All right, and that's it for the 3x. Now we have to distribute the 1. Positive 1 times negative 2x gives me negative 2x. All right, and then we have to multiply the positive 1 times the positive 3, which gives us plus 3. Again, we are multiplying to get rid of the parentheses. And now you'll notice we have no parentheses left because all the multiplication has been done. Now it is just an addition problem of combining like terms. I do not see any other 6x squareds, so I'm just going to bring him down. But I do notice I have a positive 9x, and I'm taking 2 of those x's away, so that is going to leave me with positive 7x's. And then, of course, my constant plus 3 is going to come down in the end because there are no other constants to combine him with. And that is our final answer. Another option, of course, when you're multiplying parentheses together, remember we talked about in class, if you're more inclined to do the box method to keep your work a little more organized, right? I'm multiplying 2 terms by 2 terms, so that's why I need a 2 by 2 box, right? So you can always do the box method here and split your terms up and then do your multiplication inside of each box with each row and column, as I'm doing here. And then, of course, remember your like terms will always lie on the diagonal. All right, so it's a nice way to keep your work organized. All right, number 14. I would say more than half of y'all missed this question on the quiz because we just happened to forget that when you have multiple terms, right, when you have plus or minus signs inside of a parenthesis, you are not, I repeat, not allowed to just square everything inside and be done with it. That only works if it was like only one term inside. Then you have factors and each factor can get the square. But as soon as you throw a plus or minus sign and you add terms inside of that parenthesis, you cannot use that power rule anymore. It does not work in that instance. So you are responsible for being like, oh, this square means I'm multiplying a 5x minus 1 times itself. And you must write it out twice. And then you are literally right back to what we just did on number 13. Recognizing that you have a parenthesis times another parenthesis. So every term in the first parenthesis must get multiplied by every term in the second parenthesis. So we're double distributing, or of course you can do the box method. Either way is great with me. All right, so here we do that. We're just going to go pretty quick here. 5x times 5x. It's not just 25x, it's 25x squared. Because we multiply, we add the exponents. And then if 5x times negative 1 is negative 5x. Now I distribute the negative 1 to everybody, which gives me another negative 5x. And then negative 1 times negative 1 is a positive 1. And then, of course, we want to combine any like terms, which I only have right smack dab in the middle. So I'm going to bring down my 25x squared first because he's got the highest power. And negative 5x's and 5 more negative x's gives me a total of negative 10x's plus 1. Okay. All right, I'm going to put a little note here. All right, when you see a problem like this, you have to write the binomial twice. Right, you are responsible for doing that. That looks like a weird twice. Let me fix that. Write the binomial twice. All right, then multiply. All right, number 15 is great because it's just one giant parenthesis, right? We don't have multiple parentheses, but we do have a multiplier in front. So every term inside, right, has to get multiplied by the negative 4x. So again, just please remember your rules, right? If I'm multiplying a negative 4 times 1, there's an understood 1 right there. Well, that just gives me negative 4 because numbers work just like numbers always work. But I also have an x times an x squared. And when we multiply, we add the exponents. So multiplying an x times an x squared is going to give me a completely new term, x cubed. All right, then we're going to multiply negative 4x times positive 3x. Again, there's an understood 1 right there. Let me change that, put that in pink. And that is going to give us negative 12 when we multiply negative 4 times 3, but x squared when we multiply the x times x. And then we need to multiply negative 4x times positive 2. So that would just give us negative 8x. And I don't see any like terms here. We got rid of the parentheses by multiplying. Now it becomes a combining like terms problem, but x cubes, x squareds, x's. None of those are like terms. So this is my final answer. I cannot take it any further than that. All right, number 16. This is a binomial times a trinomial. So you're still gonna have to double distribute, but you have 3 different terms over here that you need to double distribute to. If you think it'd be a good idea to do the box method here to keep your work organized, I would probably agree. I'm going to go ahead and do it that way since because there's lots of terms going on here. So this is 2 terms. This is 3 terms. That's telling me I need a 2 by 3 box. So I'm just going to kind of make a little skinnier box. It's a little bit longer because there's my 2 columns for my negative x plus 1 binomial. And then I need 3 rows to accommodate my 2x squared plus 3x minus 1 trinomial. And now you just get to use all your multiplication rules, right? So again, 2x squared times negative 1x is negative 2x cubed, because when you multiply, the term changes. When you add, the term does not. Okay, so x squared times x's are x cubes. And then I do 2x squared times positive 1, which gives me positive 2x squared, right? Because multiplying by 1 doesn't change anything. Then I'm multiplying positive 3x times negative x, so negative 3x squared. Do you notice how I'm putting a sign in every box? That's so important, right? So when you're about to finish off the problem here in a second, you know exactly whether each sign is positive or negative. All right, positive 3x times positive 1 is positive 3x. Negative 1 times negative x is positive 1x, or just positive x. And negative 1 times positive 1 is negative 1. And if you've done your box method correctly, all your like terms should lie on the same diagonal, right? My x, there's only one x cubed, he gets his own diagonal. There's only one constant, he gets his own diagonal. And now it's an addition game, right? Now, once you've done the multiplication by doing the box, right? You've done all the multiplying. Now it's an adding game, right? Where you're adding all the like terms together, okay? So here we go. I only have the 1x cubed, so we're just going to bring him over. But I have positive 2x squareds minus 3x squareds, which is going to give us negative 1x squareds. And then I have positive 3x's and positive 1x, which gives me positive 4x. And then, of course, our constant of negative 1. So that's the box method, which I really like for problems that are kind of big, like bigger than the other kind of problems. But if you don't like the box method, you totally don't have to do that, right? This is literally just a multiplication problem from the beginning, where we are taking each term in the first parenthesis and multiplying it times every term in the second parenthesis. All right, so if you just want to do double distribution, just like we were doing earlier, it's the same exact problem. All right, moving on to the next page. I'm going to scooch that down here a little bit. There we go. Now, these are the laws of exponents, right? So we already kind of talked about the laws. This is where some of y'all struggled on your quiz, because I need you to understand that there's a difference between this problem and this problem up here, or any of these problems on the previous page. Do you notice how all these problems, these are polynomials that have plus and minus signs all over the place. This problem right here has no plus or minus signs, not a single one. This is all multiplication. If you want to, you don't have to do this, but if you want to, you can split every single factor and give it its own little multiplication dot, but there's not a plus or minus sign anywhere to be found, right? So I'm literally just multiplying everything that I can. The 2 doesn't have any other numbers to get multiplied by, so I'm just going to bring him down. But I can only multiply things that have like bases with exponents. So I have a c squared times a c cubed. Well, we just talked about this up here. When you multiply, you add the exponents, right? And that's the same rule we're using down here. Right, so this is going to be c to the 2 plus 3, so c to the 5th power, right? You add the exponents. Add the exponents. When you're multiplying and trying to merge like bases together. I'm trying to get all my c's written as one cohesive c instead of 2 separate c's, right? So I'm just putting them all together. And then, of course, we have the d to the 4th times d to the 6th, which is going to give us d to the 10th. And that's our final answer. Again, no plus or minus signs to be found, because there were no plus or minus signs in the original problem. Okay. All right. Now this guy, he is different because he has a power on the outside of the parenthesis, which means it, just like it does with distributing, we have to get rid of the parentheses by getting rid of the power. And the only way to get rid of the power is to take all three factors, 2c squared and d to the fourth, that's three different factors, and we have to give them all the third power. So this becomes 2 cubed c to the sixth, because when it's a power to a power, you multiply the powers. Okay, I'm gonna write that over here. Power to a power, multiply the powers. And you only have to do that when there's a power outside the parentheses. Other than that, it's always adding the powers. Power to power, multiply the powers. That is so sloppy, I'm sorry. And then we would get d to the 12th. And yay, we got rid of the parentheses by distributing. I don't want to use that word, I'm sorry. By giving every factor inside their own little personal cube that was on the outside of the parentheses. I would be totally fine with that answer on the test. If you want to, though, you can go ahead and type in your calculator or in your head 2 to the third power, which is 2 times 2 times 2. That is 8. So if you would rather simplify the actual numerical part of your answer and write it as 8c to the 6 d12th, I'd be totally cool with that. All right. Moving on, this is from the other day when we had fractions. It is absolutely no different than what we just talked about. When you have a power on the outside of the parenthesis, everybody gets the power. It doesn't matter if it's a fraction and you have stuff in the numerator and the denominator, everybody gets the power. So this is simply just going to be rewritten as w to the 8th, x to the 8th, all divided by y to the 8th. And that's your final answer, because I don't have any other w's, x's, and y's to merge together. But we did get rid of the parentheses, and that's what simplify means. Simplify means to get rid of all the parentheses and merge all of your like bases together, right? So it's the same steps every time. All right, this one, this is again, just like number, whatever that was over there, 17, where this is just a straight up multiplication problem. And if it helps you, split all your factors up. This doesn't have to be the only multiplication, Dot, because this problem means -2 times x times y times, remember there's an understood -1 right there, times x times y squared. So if it helps you to split up and see all the little independent factors, now to simplify, you're just merging all the like bases together. And by like bases, I'm talking about -2 times -1. Which is just +2. Then we have x times x. Well, we're merging bases, so we add the exponents. And then last but not least, we have a y times y squared. And again, that's going to give us y cubed because of all these little understood ones. Right? And we're adding the exponents to figure out how many total y's we have in that multiplication chain, right? And that is our final answer, right? So simplify means get rid of the parentheses and merge all your like bases together, but you just got to know your rules, okay? All right. Last few really quick, our application problems. It says make sure that you define your variable. Right? And so we want to make sure we know what we're talking about when we set up an algebra equation. Students from Mr. Cruz's class are going on a field trip to the Dallas Museum of Art. Each student is given at most, oh my goodness, I'm going to highlight that, at most. That is an inequality word. At most, at least, maximum, minimum, right? These are your key phrases that tell you that you are dealing with an inequality and not an equation. Okay. All right. So they're given at most $19. This covers 2 meals that cost X dollars plus $7 worth of snacks. All right. Well, they're kind of telling you, which is kind of cool. They're telling you exactly what X stands for. So I'm going to put that over here. So X is the cost. This covers 2 meals that cost X dollars. Okay. The cost of meals. Now, I'm well aware that these are some pretty small numbers, and some of you guys can just logically figure out this answer in your head, but you have to write the algebra inequality and solve it, right? Even if you can do it in your head, you have to be able to interpret that into an algebraic situation on the paper, okay? So here we go. 2 meals cost X dollars each. Okay, so that means we have 2X, right? 2 meals that cost X dollars plus $7 worth of snacks. I wish they would have put, I'm going to kind of put a word here because I don't really like the way this reads. Sorry. 2 meals that cost X dollars each is really what they need there. It's kind of misleading. I don't like the way that's written, so I apologize. This covers 2 meals that cost X dollars each plus the $7 they have for snacks. So how much do they spend per meal max? Okay, again, there's that max, short for maximum. That's another indication if you didn't catch it with the at most, right? Hopefully you catch it with the max, that it's an inequality. So remember this, the 2X plus 7, this is how much each student is spending, right? This is the money that each student has, but they only have $19. So that means the amount they spend has to be less than or equal to 19 because they don't have any more than $19. So the amount they have to spend has to be less than 19, or if they spent exactly $19 on the dot, that would be okay too. So we want that equal to bar. Okay, and so that is our algebra inequality, right? So we're just going to solve it. It's just a normal little two-step algebra inequality, right? So we're going to subtract the 7 to the other side, which gives us, I'm going to have to go over here. So 2x is less than or equal to 12. And then, of course, we'll divide both sides by 2 to get that 2 multiplier out of the way. So x is less than or equal to 6. And you must have a label on any application or story problem. 6 what? $6. Right? So you can spend at most $6 per meal max. Okay. All right, moving on. When Kala went to the mall, she spent a third of her money that she brought on a new outfit. Half of the money she brought on food. If she spent $45 total, write and solve an equation that determines how much she arrived with. All right, so the first thing we're going to do is tell our reader what the X stands for in our problem, which is always in your final sentence. Write and solve an equation that determines how much money she arrived with. So that's exactly what X stands for. How much money she arrived with. Oops. Right, because we need our reader to know that. All right, so it says she spent a third of is a multiply word, right? Of means to multiply the money. Well, we just said that the money was X. So a third of, let me write down multiply. Right, this is a multiply word, right? So 1/3 of the money. So 1/3 times X, right? So the sentence is telling you exactly how to write that. All right, and, which would be a plus word, right? So plus. And then, of course, we have, I'm trying to get back to green. There we go. Half of the money. There it is again. So half times the money. So if the money's mentioned twice in the sentence, then we know we need 2 X's. She spent exactly $45, which is how we know that this is an equation. Plus, they told us anyway. And voila, right? So that is our algebra equation. Now it's got a lot of fractions in it. You're more than welcome to, because these are technically like terms, you can totally add the X's and get a common denominator. Me personally, I'm going to multiply every single term by the least common multiple of 3 and 2 to get rid of my denominators, which would be 6. We talked about this earlier in the video. right? So every single term is going to get multiplied by 6. Please don't multiply by 3, thinking, oh, well, I'll just get rid of this denominator, because multiplying by 3 would not get rid of the second denominator. So you want to pick the least common multiple to just get rid of all of them in one step. This is a really important skill when you get to upper level math, right? You're going to do this a lot. All right, so now these don't cancel because 6 times 1/3 is 2, right? So that becomes 2x. Again, use your calculator. It's there for you to help you out with any math. Plus, and again, these don't cancel, but half of 6 is 3, so 3x. Equals, then we want to multiply 45 times 6. What's that going to give us? 270, I believe. And there you go. Now you've got this nice, pretty algebra equation where we have like terms, right? We've got 2x's plus 3x's on the left, so we can go ahead and merge those together. And then, of course, at this point, we need to actually start solving for x, right? And getting the x by itself by moving the 5 multiplier to the other side by division. And that's going to give us our answer. What are we going to get? 52. Right, and 52 what? $52 is how much she came to the mall with. All right. Oh, we got 2 more, or 3 more, sorry. Here we go. This is the exact same question I put on your homework the other day that I told you it had a really weird wording, but it was like super simple, right? It says Parker wants to compare the rate. Anytime you see that lingo in a problem, that means they want you to solve for R. R standing for the rate. Okay, so this whole big thing is just one fancy way of saying just take this formula for simple interest, I equals PRT. Right now the I is solved for because he's by himself, I equals, but we want to rearrange it and solve for the R. Well, we talked about basically this exact same question earlier in that literal equations problem. The R is just simply getting multiplied by the PT. So we know that we can just divide both sides by PT, because the P cancels over here, the T cancels over here, and that is how we get the R by itself. So this is just a big, very wordy story problem that's literally just asking you to solve for the R and solve the literal equation. I'm gonna put little things on here to make that look like an I. There we go. All right, number 24, Miss Burkhead recently added 2 horses to her family. They eat so much. She would like to replace her grass. Help her find an expression for the area, there's our key word right there, area that she will need to cover if the dimensions of her rectangular backyard are 3x plus 1 times 2x minus 4. I'm a sucker for a word problem that's about rectangles because I am going to label. I don't really know which side is the 3x plus 1 and 2x minus 4, but it doesn't really matter whether it's the length or the width. Who cares, right? That's just the dimensions. And you need to focus on whether this is an area or a perimeter problem. And this is an area problem, and we all know that to find the area of a rectangle is length times width. So all they're asking you to do is take the 3x plus 1 dimension and multiply it by the 2x minus 4 dimension and give the simplified expression for that, right? And so basically we're right back to the other problems where this is clearly a multiplication problem, right? Length times width. But it's a binomial times a binomial. So every term in this parenthesis has to get multiplied to every term in the other parentheses. So this is a double distribute problem. So 3x times 3x is 6x squared. 3x times, did I say 3x? 3x times 2x, I'm sorry, is 6x squared. And 3x times negative 4 is negative 12x. Right, then we distribute the positive 1 and multiply the 2 terms times the positive 1, which is just going to keep it positive 2x minus 4. And now that we've undone the parentheses, we've undone all the multiplications. So now this is just one giant addition and subtraction problem. So you're looking for like terms, which I have sitting right here in the middle, right? These are my like terms. So I'm going to be able to add those together. That's going to give me negative 10x's when I put them together. And I'm just going to bring down my x squared term and my constant because there's nobody for them to combine with. And that would be the expression for the area of her backyard. Now this last one, it says Ms. Servin is putting a border around her rectangular whiteboard, and the dimensions of that whiteboard, oh my gosh, wouldn't you know, the dimensions of her whiteboard are the same as the dimensions of the backyard. Now, of course, they don't have the same units of measure, right? The backyard is probably feet, and this would probably be like inches or centimeters, right? The key to this one, though, is that it's telling us to find the perimeter. How much border do we need for the perimeter of the whiteboard, right? And perimeter means to add up all the sides, or you can use that good old perimeter formula, because if I add up all the sides, there's 2 lengths plus 2 widths for every triangle. So I know there's 2, oops, sorry about that, forgot my equal sign. I know there are 2 3x minus 1s, and I also know I'm going to add that to the 2x minus 4s. And then that is the math problem that I'm going to simplify, which of course just means to, again, get rid of the parentheses, add like terms, right? So we're going to get 6x minus 2, right, when we distribute the 2 multiplier, plus, when we distribute the 2, we're going to get 4x's minus 8, which makes sense, right? Because if you add up all the sides, that's what we're going to get. But we still have some like terms because we've got a 6x with a 4x. They're both positive, which that would in total give us 10x. And then, of course, we have the negative 2 and the negative 8 constants, and that's going to give us minus 10. And that would be our final expression for the perimeter. Now, if you don't like using the formula, that's all good. Then just come over here and just label every side. Oops, minus 4. And then you're literally just adding all your like terms together, right? So it's like, oh, 3x's plus 2 more x's plus 3 more x's plus 2 more x's. Yeah, that's 10x's, which is exactly what we got over here, right? And then we're adding up all our constants. We're like negative 1, minus 4, minus 4, minus 4. Oh, what do you know? That gives me negative 10. Right, so if you'd rather just add up the like terms all the way around your rectangle, it's the exact same thing as using the formula, right? So either way is totally fine with me as long as you can get that expression, okay? Sorry, I'm going to fix that 10. It's really sloppy there. All right, you guys. Well, feel free, all right, if you're watching this, feel free to go back and go back for any problems that you might need to rework. That's kind of that. And just come to tutorials in the morning if you have any questions before the test. All right. Good luck, you guys.